Today we're going to encounter some potential solutions that don't actually work, and we call those extraneous solutions. So typically those occur when you do something like squaring both sides, where maybe a negative sign gets manipulated, and then multiplying both sides by a variable. Anytime where you're dividing by a variable, you're either going to lose a solution or have a solution where that's not actually valid in the original problem. So we're going to try to check our solutions to make sure all of our solutions actually work, especially if we do one of those two things. All right, so what we do for number one is that we kind of treat it like a quadratic. So yesterday we talked about solving with quadratic formula, but today we can solve by factoring typically. Even though it's not really a quadratic, we can treat it like a quadratic because x squared, if I square that, that's the same thing as x to the fourth. So this is something that's being squared. It's just x squared squared. And then I've got 5, negative 5 times that something. And then plus 6, I have a constant. So I have a squared term, I have a regular term, and I have a constant term with no variable. So it's basically in quadratic format. And so if it's in quadratic format, you could treat it like a quadratic. So if I want to factor, I would find two numbers that multiply to 6. It could either be 3 and 2 or 1 and 6. And those two numbers have to add up to negative 5. So I know it's going to be negative and negative. So if I do negative 6 and negative 1, that's going to add to negative 7. So that's not it. So it must be negative 3 and negative 2 because that will add up to negative 5. All right, just be careful when you put your variables in. It's not just x, it's x squared. So now we're going to do the zero product property. So if I have two things being multiplied and they multiply to give me 0, then either the first thing, which is x squared minus 3, has to equal 0, or the second quantity, x squared minus 2, that has to equal 0. So at this point, you just solve, and you add 3 to both sides. You get 3. When you square root both sides, make sure that you say plus or minus. So it's x equals plus or minus square root of 3. And then I could do x squared equals 2. If I add 2 to both sides, take the square root. And again, I have to say plus or minus, so it's plus or minus root 2. So notice that I have a fourth degree polynomial. I have 4 solutions. They should all work. So one way to check your answers is to check on our calculator. Otherwise, you plug it in your head and you figure out if those solutions work. So we could write down what we're doing to check, and then I'll show you on the calculator how to check. So we've got x to the fourth, so we've got square root of 3 to the fourth minus 5 times the square root of 3 squared. And does that equal negative 6? So if I do square root of 3 times square root of 3, I get 3 times another square root of 3 times square root of 3 is 3. 3 times 3 is 9. 9 minus 5 times square root of 3 squared is 3. So that's 9 minus 15, which equals negative 6. So that works. It would also work if those square root of 3s were negative, because the negatives would cancel out with the raising to the fourth power and the second power. And I could check again with the square root of 2 to the fourth minus 5 times the square root of 2 squared and see if that equals negative 6. So that would be square root of 2 times square root of 2 is 2, and then times another square root of 2 times square root of 2, which is another 2, so 2 times 2 is 4, minus 5 times 2, which would be 4 minus 10, and that indeed equals negative 6. So if I want to check number 1 using my calculator, I can store a value that I'm trying to check. So let's say I want to check negative square root of 3. I'm going to store that into x. So first off, I need to make sure I'm out of the square root sign, so I hit the right arrow. And there's the store button, and I can store it into any variable I want, but x is most people's favorite and easiest to use, and there's an x button, so I don't even have to hit alpha. So I'm going to hit enter. So that value, negative square root of 3, is stored in for x. So I can double check, does x to the fourth minus 5x squared equal negative 6? And it does. All right, so let's try positive square root of 3. So make sure you get out of the square root, store that into x. And then now I'm using positive 1.73. Now, if I don't want to type it again, I could hit the up arrow. and grab the quantity that I'm looking for, the expression x to the fourth minus 5x squared, it's going to put the new value of x into there, and that also equals negative 6. And I can do that with the negative square root of 2. And I can store that in for x. All right, and then again, I'm going to just grab this quantity, see if that equals negative 6. And then I could do one last one just to check all of them. If I do the square root of 2 and store that in for x, and then just grab this expression, and they all equal negative 6. So all 4 of my solutions work. Now, if it's obvious that the solutions work, you don't really have to check them since we didn't really break any of the rules anyway. All right, so moving on to question 2, that we've got a quadratic. So if you look at your middle variable, x to the 2/3 squared, that's actually equal to x to the 4/3. Because when I have a square of a 2/3, you do 2/3 times 2, which is 4/3. So that's equal to x to the 4/3. So I do have 9 times some value squared minus 10 times some value plus just a constant. So I'm going to factor it like a quadratic. So I need to figure out what multiplies to 1. All right, well, there's only one option for that. And what multiplies to 9? Now, 9 could either be 3 and 3, or it could be 9 and 1. So you have to check. Since I have to multiply to positive 1, it can either be both positive or both negative. But if you look at your middle term, which is a negative 10x to the 2/3, it's got to be the negative version. So if I check outer and inner, on the first option, I've got negative 3 and negative 3. That equals negative 6. So that's not going to be the one that works. All right, but if I check outer and inner here, I've got negative 1 and negative 9, and that does add to negative 10, so that is going to work. So I know that this factors into 9x to the 2/3 minus 1 and 1x to the 2/3 minus 1. All right, so now I just need to solve, and that means I'm going to use my zero product property. So either 9x to the 2/3 minus 1 equals 0, or x to the 2/3 minus 1 equals 0. And if I add 1 to both sides, I get 9x to the 2/3 is equal to 1. If I divide by 9, I get 1/9. All right, so how do I undo a 2/3 power? Well, I'm going to raise it to the third power, because 2/3 times 3 is going to be 2. So I have x squared equals, and I have to do 1 cubed, so that's 1, and 9 cubed, so that's 9 times 9 times 9, which is 729. And then the last thing I'm going to do is I'm going to take the square root. And the square root, remember, you're going to say plus or minus, so x equals plus or minus. Now the square root of the 1 is 1, and the square root of 729 is 27. All right, and then the other side, I've got x to the 2/3 is equal to 1, and I need to raise that to the third power. This one's going to be easier. So I get x squared is equal to 1, and then I take the square root of both sides. And when I take the square root of 1, I get plus or minus 1. So I have 4 solutions, plus or minus 1 and plus or minus 1 over 27. All right, I'm going to do another quadratic like. So I'm going to solve this one like t to the negative first is squared, and that's going to give me t to the negative second. So I have another quadratic. I have something squared, just a regular something, and then a constant. So I can factor. What multiplies to 2 is 2 and 1. What multiplies to 8 is 4 and 2, or 8 and 1. And then I got to see which ones work. So I know it's going to be negatives. So I have either negative 4 minus 4. That's going to only give me 8, so that's out. And the other one is going to give me negative 8 and negative 2. That's negative 10. But if I switch them around, I could have 8 minus 1 and 1 minus 2. That's better. That's going to give me negative 1 and negative 16. So that gives me the negative 17 that I'm looking for. So my variables are 8t to the negative 1 minus 1 and 1t to the negative 1 minus 2, and that equals 0. So at this point, what we need to do is solve by zero product property. So I have 8t to the negative 1 minus 1 equals 0, which is 8t to the negative 1 equals 1. And then I have t to the negative 1 equals 1/8. All right, now how do I undo a t to the negative 1? So this one, I would suggest you write it as 1 over t equals 1 over 8, right? T to the negative first means that I just move the variable t to the denominator. So now I need to multiply, I can cross multiply, and I get t equals 8. However, on that step, I did multiply by a variable. So we do need to check for extraneous solutions. So we did that, which maybe causes an extraneous solution. All right, let's finish solving the other one. We have t to the negative first minus 2 equals 0, which is t to the negative first equals 2, which means 1 over t equals 2. When I multiply by t, I get 1 equals 2t, which means 1/2 equals t. So let's double check that that really works. So we can look at 8 times 8 to the negative second minus 17 times 8 to the negative first plus 2. We're going to see if that equals 0. So this is 8 over 8 squared minus 17 over 8. That would be like 1 over 8 minus 17 over 8, which would be negative 16 over 8, which would be negative 2. And negative 2 plus 2 does equal 0, so that's good. All right, so we have 8 times 1/2 to the negative second minus 17 times 1/2 to the negative first plus 2. All right, so that means 8 over 1/2 to the second power and minus 17 over 1/2 to the first power plus 2. All right, so that means 8 over 1/4, and 8 over 1/4 is really 32. And I have 17 over 1/2, which is 34. That would give me negative 2 plus 2. That does equal 0. So we're good on that one. All right, so last problem on this page is that we have x minus the square root of 3 minus x equals negative 3. So the first thing I'm going to do is I'm going to subtract the x on both sides. So I have negative square root of 3 minus x equals negative x minus 3. And I don't like the negative sign. So if I could divide by negative everywhere, if I divide by negative 1, divide by negative 1, divide by negative 1, then I no longer have the negative sign. So I have the square root of 3 minus x equals x plus 3. All right, so now I need to square both sides. And just like in number 3, we're going to do one of these rules where we might get an extraneous solution because we're squaring both sides here. So when I square the 3 minus x, I get 3 minus x because the square root and the square cancel each other out. Now when I do the right side, I have to do x plus 3 times itself. So be careful with that. It's not just x squared plus 9, it's x squared plus 3x plus 3x plus 9, which is x squared plus 6x plus 9. And that equals 3 minus x. So as you can see, we have a quadratic, and if we were to subtract 3 and add x to both sides, we get x squared plus 7x plus 6. And this is factorable, so x plus 6 and x plus 1 give me my solutions of negative 1 and negative 6. All right, now because we did one of those potential illegal moves, right, we have to double check our answers. Negative 6 minus square root of 3 minus negative 6. See if that equals negative 3. So negative 6 minus, this will be the square root of 9. And I have negative 6 minus 3. That does not equal negative 3 because that's equal to negative 9. So that tells me that that solution is extraneous. So you have to cross off the answer of negative 6. All right, and then we're going to check one more time to verify if the number negative 1 works. So we have negative 1 minus the square root of 3 minus negative 1 equals negative 3. So negative 1 minus the square root of 4 equals negative 3. So negative 1 minus 2, that actually does equal negative 3. So that's good. So this solution is valid. So a couple things to know is up at the top, we have our rules about if we have an absolute value less than a number, it's actually going to be in between. So we call this the and situation, where we have u is less than a and it's also greater than negative a. For the second one, we have absolute value of u is greater than a. We'll call that the or situation. So either u is less than negative a or u is greater than a. A nice way to remember that is LAGO. So less than is and greater than is or. All right, so this one is greater. So greater tells me that that is or. So I'm going to do x is greater than 2 or. Now when I do the second version, I have to flip the sign and I flip the number to be a negative. So that's my solution, right? If I were to draw this on a number line, I'd have less than negative 2. So I'd be less than or left of negative 2 with an open circle. And then here's 0, here's 2. I would be greater than 2, so to the right of 2 with an open circle. But we're going to do interval notation. So think about what do these arrows represent. So we have negative infinity to negative 2 with parentheses. The or symbol is a union symbol, so a big U, and then positive 2 to infinity. Remember, infinity never has brackets. It's always parentheses. All right, the next problem is absolute value of x is less than, and less than is equal to and. So this is going to be x is less than 2, and I'm going to flip it, so x is greater than, and flip the number to negative 2. So that means that I'm going to have the in-between situation. We're going to be less than 2, so we're going to shade to the left, but at the same time, we're also going to be greater than negative 2, so we're going to shade to the right, which means you're really shading in between. So for interval notation, we're just going to go from negative 2 to positive 2 with parentheses since those were open circles. So this one is the and version. So 3x plus 5 is less than 17 and 3x plus 5, we're going to flip it to greater and then flip it to negative 17. So now you just solve these and you get 3x is less than 12 and x is less than 4. And we have 3x is greater than negative 22. And when we divide by 3, we get negative 22 over 3. So it's going to be in between those two numbers. So we have positive 4 and negative 22 over 3. And we're going to shade in between. So to the right of negative 22 over 3, but to the left of 4. And as an interval notation, we're going to do negative 22 over 3 comma 4 with parentheses. All right, last problem is the same expression, except this is an or. So 3x plus 5 is greater than 17, or 3x plus 5 is less than negative 17. So if I subtract the 5, I get 12, divide by 3, I get 4, or subtract the 5, I get negative 22, divide by 3, I get x is less than negative 22 over 3. So my shading for the negative 22 over 3 is to the left, and for the 4, I would be shading to the right, which means as an interval notation, we want to go from negative infinity to negative 22 thirds with parentheses, and we use the U symbol for or. We go from 4 to infinity over here. So that should be our final solution. And that's all for day 2 review. And if you have any questions, please ask your teacher.